rise above the static, dissecting issues diplomatic. With mics in hand, they brave the storm of clashing views and norms transform. The Pundits Podcast, bold and true, shining light on red and blue. Through heated takes and reasoned thought, they seek the truth that can't be bought. From climate change to foreign ties, they parse the spin and sift the lies. No stone unturned, no topic taboo, as left and right come into view. The Pundits Podcast, bold and true, shining light on red and blue. Through heated takes and reasoned thought, they seek the truth that can't be bought. From climate change to foreign ties, they parse the spin and sift the lies. No stone unturned, no topic taboo, as left and right come into view. The Pundits Podcast, bold and true, shining light on red and blue. Through heated takes and reasoned thought, they seek the truth that can't be bought. In times of strife when tensions flare, their steady voices fill the air. With wisdom gained from years gone by, and hopes for brighter days tonight, the Pundits Podcast marches on their epic quest, not yet done, to understand our changing world and keep democracy's flag unfurled.
Hey everybody, this is Razib with the conversation, and I'm here with Josiah. How's it going, Josiah?
It's going mighty fine.
It's
How are you
it's real, right? As they say.
If it's not real, then what is real?
Yeah, that's okay. That's a different podcast, different conversation. We are not going to talk about what reality is
Pivoting.
today.
We're pivoting to all
Yeah,
metaphysics.
Yeah. So this is not like Bob Wright's podcast.
Right. Not yet. I have never done psychedelics, so I couldn't speak to that aspect of reality. This isn't Rogan.
All right. So we're gonna I think you chose I think most of the topics this week. So first of all, you picked the Scientific American endorsement to talk about that.
Yes. So big news. This could upend the election. Scientific American, for only the second time in its 179-year history, has decided to endorse a candidate in the presidential race. And in a big shocker, that candidate is Kamala Harris. They endorsed Kamala Harris. Actually, when they announced this, they said this is only the second time that they've done an endorsement. Of course, the last endorsement that they did was in 2020, and you'll never guess who they endorsed in 2020. It was not Donald Trump. It was the other guy. But this is provoked. Actually, I've only seen negative. I didn't see a huge amount of reaction to it. The reaction that I saw was mostly negative from people who were not necessarily Republicans or MAGA people or whatever. They don't care. But what you might call like non-woke liberals and science people who thought that this was out of keeping with the mission of science to try and get involved in politics in this way. The defenders, I did see one positive, which was from Adam Rutherford, who said, "Oh, this is good because science is political," which is typical for Adam Rutherford. I don't think he really thought through the implications of that, But I did read the editorial, and I will say, first of all, Scientific American, I mean, it's a magazine. It's not. So there are Nature, there are other journals that actually publish scientific research, other things like that. There's science venues, and Scientific American it's run by journalists. They do publish things by scientists sometimes, but it's for a popular audience. So it's not exactly a scientific publication, but it does have a good reputation. A lot of people in science, I think, particularly when they were young, have fond memories of reading Scientific American. You could learn stuff from it. It has, I would say, in recent years, particularly under the current editor, Laura Helmuth, I believe is how you pronounce it, is gone in a more overtly.
Dr. Laura Helmuth.
Right, yeah, exactly. It's gone in a more woke direction, and there have been a number of kind of almost self-parody type of articles. I saw there was an article about how denial of evolution is white supremacy. There was one about Jedi. So DEI, everybody knows DEI, diversity, equity, and inclusion. Some people, I guess, had started using the acronym JEDI, which of course has the D, the E, and the I in there, and then the J, I guess, is joining. I don't know what joining is what the J is supposed to mean, but anyway, they were using this, and they ran scientific art. And hierarchical and not appropriate for social justice. They've, of course, you had your own encounters with Scientific American over something that they published when E.O. Wilson died, that was not only very critical, but made some basic scientific errors about what a normal distribution is and other. I mean, it was just very stupid. So they've done they've published a lot of stuff that is kind of woke and maybe not in keeping with the high standards of science. It seems kind of not just middlebrow, but some of it kind of bleeds into lowbrow types of arguments, in my opinion. And this is very much Laura Helmuth on Twitter, or X, I should say, is like magnified a lot of this stuff and said some, kind of stupid stuff. So people were lamenting this. And my view is they were limiting it mostly because they thought this is going to degrade people's trust in science and in Scientific American as an institution. And I think as far as Scientific American goes, that's good. You should trust institutions when they're trustworthy, and at least in its current iteration, it's proven itself to not be trustworthy. So from that point of view, I would say it's a positive. I don't know that it actually does degrade their reputation that much, because, as I say, like, MAGA people are already kind of hip to like what Scientific American's about, and most of the readership is probably pretty liberal and was already voting for Harris. So I don't know, like, will they even care one way or the other? That was kind of an argument, is like, who cares?
Yeah. Okay. So I got a couple things to say about this. I know Laura Helmuth a bit. I mean, not well. We're not friends, but we're acquaintances. She actually kind of tried to recruit me to Slate as a scientific contributor, as a regular scientific contributor 10 years ago. And I ended up writing a few things for Slate, partly because of her. What? So yeah, okay. 2014 was different. And she recommended me for some other projects actually too. So we were friendly. We were not friends, but we were friendly. So I do know her a little bit. I think she does have a PhD in cognitive neuroscience, so she does have a scientific background. But
she does,
Yeah,
I'm sorry to
yeah,
interrupt you. Maybe you could correct my impression here, but I have, like a PhD in neuroscience in general, I would consider that a positive indicator. But if someone gets a PhD and then goes directly into journalism, um, to me, that's an indication that something went wrong. Like,
yeah. That's fair. That's fair. Like they didn't even make an effort for a regular scientific career,
right.
whether it
It's
be in industry or in the academia.
Yeah, it's one thing if take Colin Reich for example. He obviously was blackballed, or obviously, I will say he was blackballed and was not able to get a academic posting because of some of the stuff that he had written. And so, in there, that's not necessarily a uh, indicator of his like scientific chops, right? But if someone, I don't know, okay, like obviously it's a hard thing to get a PhD in neuroscience no matter what. But it is maybe slightly degraded if someone goes from that directly into journalism. It's just my gut reaction. So I'm sorry. Go ahead.
Sure, sure. No, that's fair enough. I have heard. So I don't know if I should say this, but I will say this. Not everybody at Scientific American agrees with her. Okay. So what agrees with her insofar as, I mean, she's woke. She got woke, or she is woke, and she's pretty explicit about her political commitments. And she's told people about her political commitments, because people have told me, and they're a little annoyed that she's so explicit about it. But basically, it's all about, she wants to forward social justice, racial justice, all that stuff. Out of curiosity, and like she has, Jerry Coyne in Chicago has complained really, you know, publicly and vocally, but he reflects what a lot of people are saying, which is she's taking the reputation of Scientific American, which is part of. I've actually contributed to Scientific American actually a little bit years ago. It still shows up in Google searches, but in any case, it's part of the Nature Publishing Group, and so it's subsidized in a way. It's not, it doesn't have to stand on its own legs, but she's taking the reputation and kind of degrading it because, so there is evidence published, scientific results. There's a couple of papers on this, but that show that when you take a ostensibly neutral institution and you're explicitly political about it, it reduces the esteem or the trust in the institution
Right.
from everybody. So the interesting thing here is this was done in the context of science. What the evidence is showing is when so actually I think it was Nature did an editorial, yeah, and it showed that first of all, obviously people, right wing people, because Nature endorsed Biden or something, or it was climate change. I don't remember. Yeah, there's a bunch of different things it does, but Biden was the big one. And people who were Republican didn't really care, but people who are Democrats also trusted Nature less because,
Right.
I mean, it's just like, okay, well, if they're motivated by the same base political biases as me,
Mm-hmm.
why should I trust them any more than anybody else? So, when you have an objective, ostensibly objective third party, that party can impart some credibility to your position. But if it's no better than you, then who cares? And so what the evidence is showing is when objective third party institutions or organs of adjudication judgment engage in obvious partisan behavior and they tell you so, its status actually just drops overall.
Yeah.
The same thing happened in journalism when, a couple of years ago, they were explicit about, they were like moral clarity. And then earlier than that, it was like, well, journalists should just like be honest about their biases. I actually thought that was because I actually like dig openness, but I thought in theory that was good, but it actually hasn't turned out to be good because journalists being open about their biases also just seems to allow them to be more biased now. Because like, well, I was open about my biases, so I'm not even gonna try.
Right. Yeah. So it makes them more explicitly biased or blatantly biased and that also leads to less trust in
which is what
journalists,
we see.
which is what we see. And depending on how biased they were before, maybe like again, that's not wholly bad, I would say. Although it can be. I mean, it would be nice to have some standards. I do wonder. I was thinking about this because there are these I did see these studies that as you say, show that when an organization gets political, even everybody trusts it less, even liberals, and that's plausible. I think that's probably right. Although I did step back and was like, how much do I actually believe these studies? I mean, maybe I know we've wanted to talk a while about.
Yeah, this is like a meta science issue that always crops up because I have said many times, I've said I believe that the study is correct, but I don't base that belief at all on the study.
Right, right,
Sometimes there are things that are true, but you
yeah,
know that the study is just like really not. It's neither here nor there. It could be just be noisy crap. Who knows?
right. I mean, my general, and there are exceptions, but I have gotten to the point in my life where I view social science studies in a lot of areas as guilty until proven innocent because there's just so much stuff. And partly it depends on the discipline. So if it's sociology, I just don't even look into it. I know we have a mutual friend, Gabriel Rossman, who's a sociologist. He seems like a great guy. I'm sure, he talked about his research, which is not a political topic. He seems like a pretty rigorous guy. So maybe that's okay. I don't know. But on the other hand, I'm not going to be basing a lot of opinions on it. Cultural anthropology, no. Psychology,
I do have to say something here.
yes.
I talked to Greg Cochran about this, and I've tweeted about this. When it comes to sociology and cultural anthropology, when they say something in one direction, to me, that's actually evidence that the opposite is probably true. So it actually does give me information. It's not random. I'm like, oh, okay, yeah.
Yeah, maybe I should update. But like a lot of psychology, there's a few subfields that seem to have held up pretty well, but there's just like a lot of stuff where no, there's too much uh that has not held up, and we know from the replication crisis, we know from political bias. There was a story a couple weeks ago, maybe a month ago, where audit studies are a big deal, where they send resumes to people, and some of the resumes are from a person with a stereotypically black name, and some of them are from a person with a stereotypically white name, but otherwise they're identical. And what the published research shows is that if you have a stereotypically black name, you get called for an interview less than if you have a stereotypically white name, right? And there was a researcher, I forget the person's name now, but they were saying they had done a study that was actually about something else, but it included this information, and they found there was actually no difference in their data. There was no difference in callback or whatever, no evidence of discrimination based on race in this way, and they couldn't get it published. People kept rejecting it because they're like, oh, well, you found that there's no racism, so that must be wrong, right? So this is obviously, to me, uh, that should call into question like the audit research in general. If it's like, well, they're only going to publish the study if it finds one result, then you can't trust that result when it comes out. It's the same
Yeah,
thing.
so I mean, that's a lot of this is like the file drawer effect. Well, I mean, I'll tell you something. I mean, not that many people listen to us, so I think I can say this, but and I'm
We're not on
yeah.
video yet, but like Razib, just even though he's in his apartment, he like looked around to see who else is listening while we're recording.
Well, okay, so I was talking to basically I have heard so there's something called the file drawer effect where you just don't publish certain things. So there's certain things that, so for example, if you find that actually racism against whites is stronger than racism against um blacks in some I don't know field in like say job searches, I don't. If you're a junior academic, you probably shouldn't publish it. You should probably just like let someone else publish it, or publish it in the Journal of Matt Walsh Studies and never get an academic job. I mean, there's like no, no one's gonna like believe this, or they might believe it's true, but that's not the point. There's a certain narrative of systemic racism. So I heard that there was an economist who found that there was basically a strong correlation of greater mortality, and so you correct for certain confounds. Supposedly, this is so. Who knows if the correlation is just an observational thing? But I think they control for all the causal variables. But basically, the more black doctors you have in the hospital, the more your mortality increases. Okay.
Yeah. This,
Not
right,
yeah.
right,
Yeah,
right.
not a publishable. Now you could say like, oh, it was like the patient stream, blah blah blah. But of course, if you're an economist, you try to control for all that stuff, and this effect held up. So I mean, what is a model that you could present for this? Well, it could be there is a good amount of evidence that doctors who did less well in medical school, uh, they're sued more often. There's all sorts of problems. They're frankly just not as good. And so if you have affirmative action, so this is the story you could tell. Yes, you could write a paper like this, but like that is the paper you're going to be known for the rest of your life if you're an economist in academia. It is not a result that anybody wants.
Yeah, the only way you could do it is you would have to come up with some creative way to say that like this is proof of white supremacy or systemic racism or whatever. Like the hospitals that have more black doctors must be getting less funding. I don't know what you would say.
Yeah,
But yeah,
well, and I want to go back really quickly to Scientific American because I loaded it up. I loaded it up. I loaded up the page scientificamerican.com. I'm going to tell you some of the stories, okay? Just so the listeners know, because I think this illustrates the problem. Chickadees show how species boundaries can shift and blur. This elegant math problem helps you find the best choice for hiring, house hunting, and even love. The strange story of the algorithm meant to solve life, the universe, and everything. The history of sickle cell disease is essential for understanding modern medicine. And then you have the Kamala Harris endorsement. You have some other weird stuff like here's what the manosphere gets wrong about cuckoldry. Yeah, that's a little weird. you know, I don't know, but most of the stuff from the titles doesn't look that weird. There's
Right.
still many writers that are right, and I know that there are people in the House who are old school scientific journalists who are not happy with the ship. How Lara has kind of changed the branding to be more politically involved. But the reality is, most of their stuff is still the same old stuff that they were always publishing. But what are we talking about? We're talking about like that one editorial that they have. So it's changing the whole image of the magazine without changing much of the substance. And now people, I mean, I think there are people out there who might be interested in Scientific American purchasing a copy to read some of the science articles, but actually they would never do that now because they will hear that, oh, well, it's just a political magazine now.
Yeah, that's possible. I mean, certainly this is something that you see with a lot of publications. I think my guess is that there's probably even certain staff, like the Manosphere cuckoldry article. Whoever wrote that, if it's a staff member, that's probably a staff member where they write most of the like woke culture war-y stuff, as opposed to this more sciencey articles. There's probably dedicated staff who just like, it's not like they're doing half and half, right? They're probably doing one or the other. This is my impression from other publications, like the New York Times, for example. They used to
you can tell by the byline what's gonna go down.
Don McNeil or is it Carl Zimmer? Then
Pamela Paul.
Yeah, those tend to be okay. And then they would have like Amy Harmon, talking about like how milk is racist or something, right? So you could definitely like they're both their job title is the same, but you could tell, like, if you know to look at who is writing it, you could say, okay, all right, fine. So there's a little bit of that. But this is, I think, it's a more general problem even than Scientific American, because, of course, the nature of political reality right now is that a lot of elite institutions are dominated by partisan Democrats or left wingers at various times, especially journalism. That's kind of always been true. The academy, it's been sort of true, but not to the same extent. I think there can be a big difference between if your department is 20% Republican versus 5% Republican, right? If you're 20% Republican, okay, that's a distinct minority, but
No.
there's enough of them around that you have to be careful. You can't just be like,
Yeah.
yeah. Whereas if it's
Well,
5%,
yeah, I will say, I've noticed over the last like 20 years of my, being on the edge of or in academic science, I've noticed it's like it's gone from like 1 out of 5 Republicans to 1 out of 50 Republicans. I mean, I'm exaggerating a little bit, but
well, some
not
departments
that.
an exaggeration, yeah.
Yeah, and some of it is what is it? So yeah, so some of it is actually the weird thing is people. Some of it is not just academia's problem. There's been some negative polarization. So, for example, Republicans have kind of got dumber optically. They present kind of a dumber, whatever anti-science face, and so there's like David Gorski. Some of you probably have heard of David Gorski, or he like runs science-based medicine. He's an MD, PhD. He's super woke. He's like, tangled with Jesse Singal about the trans stuff. And somebody on his science-based medicine site that wrote something that wasn't as trans-friendly as he wanted, they eventually like deleted the post and kicked him out of science-based medicine. All right, and like he's talked shit about me on Twitter recently, or over the last like 10 years. But here's the thing: I know David Gorski back to 2006 at Science Blogs. David Gorski was a moderate Republican back then, and in fact, he talked in the forums. I mean, he was like turning away from the Republican Party around then, but he talked about and David Gorski is about 10 years older than me, so he's older Gen X, and he talked about how when he was a kid, when he was a teenager, a young adult, he was a pretty enthusiastic. He was a pretty enthusiastic Reagan Republican. Like he's a big fan of Reagan, and so this is the background. He's not like super far right, I would say, but at one point he was a conservative Republican. As a teenager, as a young adult in college, and even until like around 2010, he was still identified as a Republican. He was still politically moderate. I talked to him. He was definitely a politically moderate. He was not a liberal. He was not woke. Nothing like that. I kind of lost touch with him after I left Science Blogs in 2010. And also, I started noticing, and he would like tango with denialists, like Nazis and all sorts of weird, people there. And around 2010 with the Tea Party, I think he decided he's not a conservative anymore. And over the last 14 years, he's basically woke. I'm only pointing that out in that, obviously David is an adult. He's responsible for his own choices, but some sort of like reciprocal negative polarization happened there. The Tea Party, was libertarian notionally, but it also had kind of a populist element. And frankly, that repulsed a lot of professional managerial class people. And then Trump happened and MAGA. And so it's just, the aesthetics. It's not even the substance, it's the aesthetics. Because Trump is less religious and more moderate than what came before. I mean, like, Trump doesn't even know what creationism is.
Right. I mean, the trend, I'm pretty sure that this trend of educational polarization or whatever has been going on for a while. I suspect that it has that part of it has to do with the end of the Cold War, because during the Cold War, you have a clear reason for there's a lot of smart people could be more attracted to Republican Party conservative politics because of the anti-communism elements. of it. Uh, for various reasons, intellectually, or they work for like this defense stuff, or it's just like a different issue set. And since then, for whatever the reason, you have had a realignment where, and Trump has definitely accelerated this, where a lot of people who in the past would have been moderate Republicans, professionals, are now basically Democrats. And the flip side is a lot of working class people who in the past would have been staunch Democrats are now Republicans. This is the kind of like Missouri versus, you look at like the states that have flipped, right?
Missouri versus Virginia.
Missouri versus Virginia, or, Ohio versus Colorado, right? I mean, if you go way back, California used to be a Republican stronghold, right? Whereas West Virginia was a big Democratic stronghold. So that's the kind of that's the shift that we've seen. It's continuing to happen, and I mean, you're going to polarize on something, and it's always going to cause problems. But the educational polarization, I think, has kind of been bad for both parties or political wings or whatnot. On the right, sometimes you like have a lack of human capital sometimes, and then on the left, the kind of it's led to groupthink, and you get untethered from like realities or whatever, because you don't have you need a Republican in the room to just kind of like rein you in. And a lot of people, I think, my guess is, even in these departments that are 50-1 Republican, a fair number of the Democrats, yes, they're Democrats, but politics is not their overriding concern. Maybe they find the person who wants to talk about social justice at every department meeting a little annoying. So they can like back up, the Republican if they're saying, hey, we shouldn't be politicizing this or whatnot. But if the Republican isn't there, or if there's so few that they kind of have to hide, then it creates a very different dynamic.
Yeah, you're 100% correct from what I know in academia. And the people who've been pushing back on the Scientific American thing, they haven't been like you said, they haven't been MAGA, they haven't been Republican, because they don't really read that journal anymore. It's usually like centrist libs,
Yes, right. Yeah, people who they're reactionaries because they want to go back 10 years to when there was
these are people that probably support Kamala Harris, but they're just like, what's the point of this in Scientific American? He's not gonna basically they're not well, they don't see the point of this sort of virtue signaling, because that's what it is.
Yes, right.
Because like the editorial does nothing except like tell your peers what you already believe. So it's it's what I mean. I guess I think why Jerry Coyne, who's a professor at Chicago, an old school paleo liberal type of guy, I would say. I know Jerry a little bit, and he's angry because he actually cares about Scientific American.
Right.
So he cares about the legacy of the magazine, and he thinks that once you lose your reputation, it's gone, right? So, it's it's a weird situation, and I don't know how much longer this can go on, because at some point people at Nature will start noticing, at the Nature Publishing Group, like, what's going on here? We're looking at some of the numbers, and probably they're just losing subscribers based on like bad publicity, because I don't think like people that aren't interested in science will start reading Scientific American or subscribe to it just because of one editorial. But there will be people who will stop because they get annoyed. Right. And I know that I subscribe to like publications and stuff like that, and I'm look, the only reason I'm still subscribed to Washington Post is Megan McArdle works there. Right. I've told her that, like, I'm like, okay, I've like come close to unsubscribing probably like once every 2 months for like the last 2 years, and then at the end I'm like, Megan works there. If she stops working there, I'm going into my settings, or I'm gonna call. I'm gonna. I'll unsubscribe. So I mean, that's just how it works. It's like people just make these irrational decisions. I guess you wanted to talk more about science, Josiah, because you put it in there.
Yeah.
The about another paper that came out of the Fourth Reich. I'd say that. Yeah. You want to like talk about the paper?
Sure. And I mean, you are the person to talk to about this. I would say David Reich, who is kind of like the god emperor of ancient DNA, you might say. He's done a lot of work. His book, Who We Are and How We Got Here, very good. Using genetics and like ancient DNA to try and learn about the history of humanity and where different groups of people who moved around. So I would highly recommend that book, even though some of it even is a little outdated, of course, because the field is moving very rapidly. But they just he and his lab just came out with a new paper, which is very interesting, and it shows that over the last 10,000 years, there's been heavy selection in Europeans for a number of
What Western Eurasians?
Western Eurasians. Yeah. Which Western Eurasians. That's like the
It
steppe.
no, it could be Caucasus samples too,
Yeah. Okay. All right.
and some steppe. Yeah.
Yeah. And I'll come back to that in a minute. But anyway, so they were looking at those samples and they found there was heavy selection in the last 10,000 years for a bunch of different traits. So body fat has gone down over the last 10,000 years. Propensity to body fat, propensity for depression and schizophrenia, interestingly, have gone down genetically. Walking pace is increased. Intelligence is increased. Education and income, the genetic correlates have increased. There's something about smoking. I don't remember which way the smoking one goes. And this is very
it went down. Smoking went down too. Smoking propensity went down.
Yeah. Okay, so this is very interesting, but I think we need to unpack it a little bit because particularly on X, there were a number of people who were like, like years of education has gone down for 10,000 years. They didn't have schools 10,000 years ago.
So years of education went up, and then it's what's gone down in the last century.
Excuse me. Yeah, years of education has went up. Smoking has gone down. They didn't have school 10,000 years ago or smoking. Like, what does this even mean? So maybe you, like, I could try and explain it, but you are the science guy, so maybe you could kind of explain what they did and like.
Yeah. So I actually recorded just for the conversation. I mean, I think a lot of the conversation people, I mean, looking at Apple, a lot of the conversation people already listen to unsupervised learning. But I recorded an hour and 30 minutes. I probably should have gone longer, but anyway, started getting just a little hoarse at the end of it. A monologue on that will post. It will post before this goes live because we record usually about 24 hours before it goes live. And I'll get into like the nitty gritty of the details and also give kind of a survey about natural selection and the genome. Like the first like 1/3 of the podcast is not about the paper, but really about just how we got here. Not who we are, but how we got here. About the paper, and then I go into the details of the paper, the methods. I guess the first thing, what I would say here is, okay, so what normally you try to do is detect natural selection in the genome by looking at modern populations and looking at the signatures, and then seeing what the signatures tell you based on a model of past history. And so obviously that works a lot, but what the great thing about what David Reich's lab can do with their like 8,000 some ancient DNA samples, whatever, right now is they don't need to look at the present and make a inference about the past. They can just look at the past, right? So that's the first thing that's great about this. And I do have to say, you know, the author list. It's not that big of an author list. I'm gonna go just like really go through it really quickly, just so that people get a sense. So Ali Akbari, I've met him. I don't know him too well. He's been working on this for like 4 years. It's just like it's I was say it was almost like a joke how long this has taken. Like he's been working on it really hard. But Alison Barton, I don't know her. Steve Ghazal, don't know. Sheng Li, don't know. Mohammed Karminjad, I don't know. Annabelle Perry, don't know. Yating Zhang, don't know. Alyssa Mitnick, she's worked on some of these papers. She's pretty good. I know her. Nick Patterson, he is David Reich's collaborator. Nick Patterson was actually a cryptographer. As a grandpa, this is his like third career. He worked for the British intelligence. Then he worked for Renaissance Technologies in quantitative finance. Made a bunch of money and wanted to figure out what he wanted to do with the rest of his life 20 years ago. And so he just walked over to Harvard and and he just started like just jumping into people's labs. So he worked with some other person initially, and then he walked by a seminar and he saw David Reich presenting, and he's like, "Oh, this chap seems interesting." So he sat. Then he just went up to David. He's like, "Hey, I want to work with you." And then he told the other professor bye. So, and so he's been working with David for 20 years. And he is a mathematician, PhD mathematician by background, and he just like invents statistics here and there to help with the analysis. Matthew Ma, I don't know. Zheng Zhao, I don't know. Alkesh Price, he's much younger than Nick Patterson, but he's kind of a mathematical savant. Uh, Basically, when it comes to analyzing quantitative statistical genetic data, Alkesh Price is he's like an oracle, right? So there are biologists who are biologists, traditional biologists that are interested in the biology. I'm sure he's interested in biology, but he's basically like he's like a logical machine in terms of like the methods papers that his lab generates. So that's why he's on. Eric Lander, a lot of you guys know, was in the Biden administration, got fired for being a dick. Is really big. He basically founded the Broad Institute. So he's been one of the, aside from Francis Collins, Craig Venter, and if you want to count James Watson, although he's a little older and a little earlier than them, he is the most important person in American genetics over the last 50 years, I would say. Eric Lander. So I don't know why he's on this paper. I kind of think maybe he's on the paper because if the paper gets any criticism, Eric Lander's on the paper. I don't know. Because he hasn't done this he hasn't, gotten into the nitty gritty of this stuff for a while. Ron Panhasi is an anthropological geneticist who has a lot of samples. Nadine Rowland and Swapan Malik. So I think Swapan, he does the data curation, the data cleaning, the data analysis, like getting the data in a good state before people do the science on it. And I think Nadine manages the lab and everything like that. It kind of helps with that. So these two people are actually pretty important on this paper because one of the key important aspects of this paper is that the ancient DNA quality here is high. We have lots of ancient DNA. We have like tens of thousands. We have like, I'm sure David Reich's lab has 100,000 ancient DNA samples. Most of those samples are not useful for selection studies because selection studies are very, very sensitive to bias in the data set or error in the data set. So what they did with this ancient DNA is they got it up to quality levels that are similar to modern DNA. Okay, and so then you can do apples to apples comparisons. And when you're looking for small effects like polygenic selection, which they do in this paper, people can't say, "Well, your data set was bad," And then it's David Reich. So those of you who have like read these sort of scientific papers, which a lot of you who are listening to the conversation have not, this is actually a small number of authors for this type of paper, this size of a paper. So I'm a little curious about that, but some of these authors are extremely, extremely high quality individuals, and they're value above replacement players, right? They are definitely like live players.
It's the Avengers of genetics.
A little bit. I mean, so you said like David Reich is, big deal. I don't know. Like I'm thinking, like I don't know if there's another human geneticist now who is of his eminence in the public sphere now. Like Svante Pabo got the Nobel Prize, right? But Francis Collins is basically retired. He's a government official, basically, or whatever. There's no human geneticist who is at David Reich's level now. I think David has, there are peers who do really great work, but like they're not known to the public. Like Jonathan Pritchard, like Jonathan Pritchard is a big deal. I mean, there's others like Rasmus Nielsen. Anyway, I don't want to get into it, but so David is a big deal. This is a big paper. There are things in this paper and I will get to them. But that are controversial and that are attracting attention. And so only this group could actually have done this in a way, because other groups probably, we were talking about file drawer effect. Other groups would have avoided some of these things, or like avoided publishing some of these things. The core here, though, so I talked about the sample size. So I think they used was it 8,000? I just want to double check because I don't want to misstate. What's their sample size here? I mean, I know that they have 8,433 West Eurasians who lived over the past 14,000 years, and 6,510 contemporary people. And I think this is like mixed up thousands genomes in UK Biobank. What they needed is phenotype information for some of these people, so that like they needed the traits. So that's why it's a smaller sample size. Like looking at like across the whole genome, although some of them, like hundreds of thousands of markers. Hundreds of thousands of markers is a lot, though. Okay, so they have the sample size. They clean the sample size, and then like third thing I want to mention, because I know it's not interesting to a lot of people, but I have to mention it. The method that they used was a generalized linear mixed model, and so one of the issues that you have with selection studies is you have population structure, and that explains some of the variation, or selection can explain some of the variation. And there's been a problem over the last 10 years, well, actually, last 20 years, of population structure being confounded for selection. And so they're really worried about that. So a concrete example is Northern Europeans are taller than Southern Europeans. This is just a fact. It is not because of diet. It turns out that when you do a polygenic risk score, Northern Europeans score higher than Southern Europeans. Okay. And then, there was an analysis of this that tried to look for selection, and they were like, oh, well, there's been selection for height in Northern Europeans upward and downward in Southern Europeans. Well, it turned out that they're Northern Europeans and Southern Europeans also differ in the amount of step ancestry they have. Northern Europeans have a bit more than Southern Europeans. And so it turned out that what they thought was selection was actually population structure, was actually population history. And so it attenuated the signal to the point where it became not statistically significant. And so this has been a major issue in selection studies for polygenic characteristics, for subtle characteristics, right? Not as much of an issue for something like lactase persistence, which is due to one gene. And so there's a huge effect. And so the study doesn't need to be highly powered. And what I mean by powered is just like you have a large sample size, and it can detect very, very small effects to statistical significance, as opposed to confusing noise with a result, which is what an underpowered study would often do with a small sample size, right? So they use generalized linear mixed model, and that basically means is you imagine an equation. The output here is the allele frequency or the allele count. And so an allele is just a genetic variant. So it's just the genetic variation. What they have, and there's a selection browser, and I'll link to the selection browser. You can see like the change over time. The output is like the change over time, and the model has an equation or a function. And what it's trying to do is like, how does this function explain the change over time of this allele, right? And so the change over time could be flat. Okay, if it's flat, like nothing's going on. But if the change over time is like linear, or if it drops and then goes back up, why is that happening? There's different things that can be happening there. It could be genetic drift. Or it could be population structure. So you can have a situation where populations come together, changes the allele frequency, and then another population comes together and changes the allele frequency again. Well, that's not selection, that's population structure. So what they have is they have a function with a bunch of parameters. One of them, obviously they're trying to account for drift, but one of them, so drift is just like noise, right? One of them is a matrix, so it's a structure that shows relatedness between all the individuals. So they're trying to account for population structure, which is, say, the difference. Well, actually, I'll be concrete about it, because there's 3 primary populations in West Eurasia that they're called, which is mainly Europe. Okay, to be explicit, is Western hunter-gatherers. These are the Mesolithic hunter-gatherers that were in Europe when the farmers arrived about 9,000 years ago to Greece first, but these are the descendants of people that settled Europe at the end of the Ice Age. These are the last Pleistocene people. These are Ice Age Europeans, the ultimate Ice Age Europeans, right? Okay, so that's Western hunter-gatherers. Then they have early European farmers who are descended mostly from Anatolian agriculturalists that started farming about 11,000, 12,000 years ago, and they started pushing into Europe around 9,000 years ago, something like that, into Greece. They were in Andalusia in Spain, they were there like 6,000 BC. They were almost there, they're almost there immediately in Spain, like 8,000 years ago or whatever. Yeah, 8,000 years ago, or like a little under 8,000 years ago. They pushed into Germany. They show up about like 7,000, Central Germany, 7,500 years ago. They didn't get into Britain until 6,000 years ago, and pretty much the same or a little lower in Scandinavia, right? Okay, so these people are Anatolian farmers. They're genetically the most similar today to Sardinians, and that's because people in Anatolia have changed because of migration from the east. Okay, so they're mostly the Sardinians. The last population of people from the steppe, this is really Yamnaya. The Yamnaya themselves are about like half Eastern European hunter gatherers, and the other half is various stuff from the Caucasus and a little bit of the Near East. So these are the three populations. And the way that the earlier studies of selection would be done would be look at the three populations. How does this explain the genetic variation? So concretely, I'll say one trait. You can look at the selection browser. So blue eyes in Europe was at like 90% 9,000 years ago. And that's because Western hunter gatherers were 90% blue eyed, right? And then what you see in their ancient DNA data is a massive crash down to like 10%, or less, like within a couple of thousand years. That's because the early European farmers had brown eyes. Okay. So it's not really selection.
Right.
Then what you see is an increase back up to almost 50% or so. Okay. Or more than 50% for the allele frequency itself. Maybe like 60 over the last, like, whatever, 7,000 years. Like, really, actually, wait. I'm gonna look real quick. Just the selection browser, because I want to be really clear on this. And so, what is going on there? Well, the steppe people also had brown eyes. So, the intuitive explanation there would be there was selection, right?
Mm-hmm.
Because like it's not being explained by the population. Well, that's what that function is doing. That's what that function is doing for all of these traits, where it's trying to take into account the population size, some noise parameter. There's a noise parameter in there, and it's trying to say like, okay, well, there's another parameter, selection S, in that equation, and does S have to be non-zero to explain the change in allele frequency, right? To a statistically significant effect. And so that's what it's doing. It's detecting S, and I'm going to look up. Okay, I'm just on the browser. There's the browser. Okay, a selection browser. So what you do, I'm gonna tell people how to do this actually. So you go to the ancient genome selection browser, and I'm gonna tell you exactly what I'm doing. So you need to find the RSID. This is not necessarily easy, but do blue eyes, SNpedia, and you'll see eye color, and it'll actually have a list of RSIDs. You can usually figure out which ones are the most useful, but I'm going to use RSID 12913832. That's the most. That's the functional one. That's the one that's really causing the difference. I'm going to put that into the search for the variant, and there you go. Searches for the variant, and I'm going to actually let's see if I can. Yeah. Okay. Yeah. So you see the variant drop, and then you see it rise back up, and the drop is due to admixture, and the rise back up is due to selection. That's what the model is telling you, and it's looking at all of these variants with this model, and sometimes it turns out you can't like statistically infer it. Sometimes you can. Another thing that they put in there is that if you change the statistical stringency, you get a much higher number of selection events. So that's what you're alluding to. And so they reduce the statistical stringency to the point where their simulations, their models indicate that 50% of the time it's going to be a false positive, but 50% of the time it's going to be a true positive. They got over 10,000 selection events. That means that there's about 5,000 selection events in the genome of West Eurasians, of these Europeans, over the last 14,000 years. That's a lot of selection events. So, yeah, I've been talking for a while. Where do you want to go next?
Okay. Well, that was a tour de force. I don't know if that's the right word, but very, very interesting. I mean, like I'm very small brained, so my question is just on a more
Yeah, Josiah's a lawyer. Just that's what he's trying to
yeah,
say.
exactly. I'm a lawyer, so I'm even I identify. There was an old Saturday Night Live skit with Phil Hartman, unfrozen caveman lawyer, which is that
That's like it's a
he would be one of the ancient DNA samples, and then he comes out and he becomes a lawyer and talks about how like the modern world is.
Your Honor, David Reich took my data without my consent because I'm just a caveman and I can't give consent.
That's right. So yeah, I guess. So the first thing, a couple things. One is why this was done on Europeans and West Eurasians. And I guess my understanding is there's probably two reasons for that. One is you have a lot more ancient samples because weather makes it easier to, preserve. Preservation, right? If it's hot, then, stuff degrades. And then the other is the scores that they're basing it on tend to be done based on Europeans because we have more modern samples because you have like some Western healthcare systems, other things where they have a lot more people a lot more Europeans have given their DNA to these companies or government or whoever. And so that's what it's based on. And it doesn't necessarily translate to people in other parts of the world, right? I mean, it could be it's possible.
Yeah, and you're bringing up an important point. Yeah. I will say another issue why we have so many we have so many European samples is not just the weather and preservation. It's also like all the different European countries. They are funding. The U.S. is different because we are intellectual hyperpower. We study everything. We fund everything, more or less. But the government of France will fund. Well, France actually is not super into DNA, but we don't get into why. But the government of Britain will fund a lot of stuff about ancient British genomes, and actually Britain has a comparative advantage in this area. They tend to focus a lot on it. But Estonia, for example, will also do it. And so you have all these little European countries that are funding their own countries' ancient DNA that have archaeology departments and archaeology traditions that were started in the late 19th century, early 20th century to kind of fulfill nationalistic purposes. And so you just have a much, much more dense scholarly treatment of these areas for historically contingent regions, as opposed to say China, which only has gotten into. Chinese are into history, but they've only really gotten into archaeology and ancient DNA over the last 10 years. They had other stuff that they were dealing with. Great Leap Forward, the big famine, and then the Cultural. They were just not doing any of that. So that's part of it. Another reason is what you're alluding to. A lot of the healthcare studies are done in European populations. The signals are stronger. One of the objections to this study, in terms of its generalizability, is that actually the ancient populations are different from modern populations, and so the portability problem that you have with genome-wide associations is applicable to these populations. I object to this in two things. One thing is, I think the generalized genetic relationship matrix is supposed to account for some of that. They are trying to overcome issues with portability. Portability also differs from population to population. So I'm just going off the top of my head. Like I've seen some portability issues where it's like, oh, the GWAS signal is 70% as powerful in South Asians, starting with Europeans as the base, and then 50% in East Asians and 30% in Africans, right? Okay, well, what that's showing you is the genetic distance is affecting it. First of all, 50% is still a signal.
Yes. Right.
Yeah, it's still a signal. It's still going to go in the right direction, right? And so they did things like instead of doing the magnitude of the selection coefficient, they just did the sign, to attenuate. They're aware of the population structure issue. Okay, but another thing to note here is that the ancient populations are not necessarily as genetically distinct as Chinese are from Northern Europeans, right? So, I'm going off memory here. The biggest difference is going to be between the early European farmers and the Western hunter gatherers at 0.1 FST, which is about the similar between Chinese and Europeans. So that's the earliest one. Most of the different genetic differences are going to be smaller than that, right? They're going to be like the differences between European populations. So this idea that they're not as portable, blah blah blah. I mean, it's a legit objection, but it's not. It's not like a total block, right? So that's an issue that's going on there, and I don't think it's as much of an objection as you would say, as some people are saying, because the pairwise FST between modern Europeans and steppe people, Western hunter gatherers, and EEF is going to be well below 0.1 because these are the ancestral populations. And a lot of the portability issues in GWAS are due to these are medical conditions, and if you're doing a predictor on somebody, and it's like got a 50% degradation in effectiveness or predictive accuracy in a medical context, that's a huge effect. Whereas if you're like studying like patterns of selection of the genome, it's not that big of a deal because you're just looking for the general pattern, right?
Yeah. And then the other thing that I wanted to talk about, this is this is a little confusing to some people. But, for example, one of the findings of this study is that genetic correlates of body fat have gone down, right? So people are naturally predisposed to have less fat now than 10,000 years ago. Obviously, that does not mean we're probably people today are probably fatter than people 10,000 years ago. Certainly we're fatter now than we were 100 years ago. It's just that the environment, there's like a offsetting environmental change. So people didn't get
obesogenic.
Right. Yeah. We live in a society now where food is so plentiful and easy to get at. If you were, let's say you had a time machine and took someone from 10,000 years ago and brought them to today, they would on average have more body fat than a person today in the same environment and vice versa. Like that's what it's saying. It's not saying that people were actually fatter back then or more depressed,
You're kind of getting at what's going on here. Well, this is what's going on. You're looking at modern populations and you're doing a genome-wide association, which is basically just looking for variation within the population and seeing what can be accounted for by variation of the genes. So you do a study in Americans, like 30% of them are obese, 50% are overweight, and then 20% are normal weight or thin, right? And you're looking at that variation and then looking for what the genes explain. And then what you're doing is taking those genes and you're seeing how they varied in the past over the time. And what they found is the genes in the Hope you enjoyed the podcast so far. To listen to the rest of it, please go to conversation.substack.com.
Two minds met on a summer's eve, each with truths they'd long believed. Words flowed like a winding stream as hours passed in deep debate. And after all was said and done, they found a thread of common ground. In listening close, they came to see a shared humanity. They spoke of justice, spoke of change, of history's weight and future's range. Their views at first seemed worlds apart, but patience bridged the divide. And after all was said and done, they found a thread of common ground. And listening close, they came to see a shared humanity. They spoke of justice, spoke of change, of history's weight and future's range. Their views at first seemed worlds apart, patience bridged the divide. It's not about who's wrong or right, but understanding others' right. In civil discourse we can find ties that gently bind. And after all was said and done, they found a thread of common ground. And listening close, they came to see the shared humanity. As dawn broke soft on dewy grass, they smiled and shook hands at last. Two souls enriched by reason talk, united in respect. And after all was said and done, they found a thread of common ground. And listening close, they came to see the shared humanity. This folk song captures the essence of a long, thoughtful discussion between two public intellectuals. It emphasizes the power of patient listening, mutual respect, and the discovery of common ground. The gentle tone reflects the common understanding they reach after their debate. Would you like me to expand on any aspect